Hey everyone, in this video we're going to talk about the difference of two squares, the factoring method, dots. So, a joke, I have one square minus another square, get it? Difference of two squares. I should be a comedian, I know. So anyway, the formula for difference of two squares looks like this. A squared minus b squared. If you have that situation, you have a plus b, a minus b. So, one of the things that's really important with dots is that we're always going to have a plus and a minus. So, the way I like to do it is whenever I know that I have to use dots, I make my two brackets. I take the square root of the first term, a squared. I put a in both position in the first position in both of the factors. Now b squared, I take the square root of b squared, I get b. And now I just need my plus and my minus, just like this. Now, a lot of the times people ask me, well, why do we need a plus and a minus? Is it always plus and minus? Yes, it is always plus and minus. We need one of each. Why do we need one of each? Because if I were to actually FOIL this out again, take a look at what actually happens. So first, a times a squared. Outside, a times negative b. So it's negative AB. Inside is BA. And last is B and negative B, which is negative B squared. So now if you take a look, the two middle terms here, the negative AB and the BA, when you add them together, they're like terms, so we can actually just cancel them out. So we're left with A squared minus B squared. So the whole point is that we need that middle term to cancel out. So we're left with something with only two terms. And another reason that this is a really easy method actually to use, because you just take a look at what we have, and what's the method called? Difference of two squares. So what do we need? We need a difference. Do we have a difference right here? Yes, we do. We have a minus sign. Do we have two perfect squares? X squared is a perfect square. 9 is a perfect square. So yep, we can use it. We put our two brackets here. What's the square root of x squared? X. What's the square root of 9? 3. And I need a plus, and I need a minus. Done. Next one. X squared minus 36. Do I have my difference? Yes. Do I have two perfect squares? Yes. I have x and x. Square root of 36 is 6. And then I have plus and minus. Done. The next one, x squared minus 144. Do I have a difference? Yes. Do I have two perfect squares? Yes. Done. X plus 12, x minus 12. And then the next one, x squared minus 64. Do I have a difference? Yes. Do I have two perfect squares? Yes. So it's just x plus 8, x minus 8. So this is a very easy factoring method, but it can get a little bit tougher. So take a look at the next couple here. So when we have something like 4x squared minus 36, yes, we have our difference. Now we have to look to see if we have two perfect squares. So we have, for the first term, the coefficient 4 in front of x squared. So in this case, for that whole term to be a perfect square, the coefficient 4 would have to be a perfect square, and x squared would have to be a perfect square. Well, fortunately, that actually is the case, because the square root of 4 is 2, and the square root of x squared is x. So, the square root of the whole term, 4x squared, is 2x. So we're going to do the exact same thing we did before. We're going to put the square root in the first position in each factor. So, just to make sure, 2x times 2x is indeed 4x squared, so we are good. The square root of 36 is 6. So we put that in the second position in each. And now we just need our plus and our minus. Also, a lot of times people ask me if it's okay if we write like this. 2x minus 6, 2x plus 6. Is that okay? Is that correct? Well, the answer is yes, that is correct. And the reason why is because the commutative property of multiplication. If you remember, a times b is the exact same thing as b times a. So, this situation right here is just a fancy way of saying A times B and B times A. It's just something times something is equal to the reverse of that. The second thing times the first thing. It doesn't matter with multiplication. So the next example, we have another situation, 9x to the fourth minus 100. So, is 9 a perfect square? Just like the last one, we have to make sure that the coefficient is a perfect square and the exponent is a perfect square. So, is 9 a perfect square? Yes, it is. Is x to the fourth a perfect square? Remember, if we have an even exponent, then we have a perfect square. So, we have 9x to the fourth. We can take 9 and we can take the square root of it and we get 3. Whoa. And we get 3. The square root of x to the fourth is x squared. So that's good. The square root of 100 is 10. And just like for always, we need our plus and our minus. And that's it. Now we look at the next one. We have x to the fourth, y to the seventh, minus 36x to the eighth. Now, is that a perfect square? Well, is x to the fourth a perfect square? Yes. Is y to the seventh a perfect square? No. And that's a problem, because now we can't use difference of two squares, because that is not a perfect square. Yes, 36 is a perfect square, x to the eighth is a perfect square, but y squared is not. So let's change that to make it so it's a perfect square. We normally can't do that, but just to give another example, let's make this y to the sixth. Now we actually can do it, so we will make our two factors. We need the square root of x to the fourth, y to the sixth. So, the square root of x to the fourth is x squared. The square root of y to the sixth is y to the third. The square root of 36x to the eighth is 6x to the fourth. And I just need my plus and my minus. So this can actually come up a lot where it looks really, really ugly, but it just winds up being difference of two squares. So whenever you see a binomial or a polynomial that has two terms, always look to see if you can use difference of two squares. It's always a good hint that that could be the case. That could be the method that we use. 25 minus x squared. We have our difference. Now we need two perfect squares. So here's the thing. This looks a little bit weird because we don't usually see the number for the constant first. We usually see the exponent, like the variable with the exponent first. But this still actually is difference of two squares. It's just reversed, but it doesn't matter because it's still difference of two squares. So we take the square root of 25, which is 5. We take the square root of x squared, which is just x. And then once again, just like always, we need our plus and then our minus. Or minus and then plus. Either way is fine. The next one, z to the eighth, y to the eighth. So, the square root of z to the eighth is z to the fourth. The square root of y to the eighth, we just divide 8 by 2. We have y to the fourth. We have our plus and we have our minus. Now, in an upcoming video, we're going to discuss a situation like this, where if you actually notice, we have z to the fourth minus y to the fourth. This actually can be factored more. This can be factored further. Because that, believe it or not, is actually also difference of two squares. So we're going to do that in one of the next videos that talks about factoring completely. So stay tuned for that one. So just for the last one, let's take a look. We have 81 minus x squared. It's just like this situation up here, where we can take the square root of 81. Even though it looks backwards, it still works, because we have our difference, and we have our two squares. The square root of 81 is just 9. The square root of x squared is x. And now I just have my plus, or my minus and my plus. It also, like I've been saying, it doesn't matter what order we put them in, as long as one's a minus and the other one's a plus.